Hi, my name is Mya, and I'm a graduate of the kinesiology program and a recipient of this year's NSERC URA. I've had the pleasure of working in the occupational neuromechanics and ergonomics lab through my time as a URA recipient, and I've worked on 3 different research projects alongside master's and PhD students in the lab. These projects included a meta-analysis examining upper extremity strength differences based on handedness, exoskeleton testing and analysis, and piloting of a study in the research lab. I'll talk about 2 of these projects today. In our lab, we've been working with the automotive industry to evaluate upper extremity exoskeletons for industrial work. This technology allows for support of the upper limbs during working tasks. There are several settings with different levels of support and different ranges in which these support levels are used. Our industrial partners need help to implement this technology effectively. So this summer, I've been working on the dynamic testing of the exoskeletons using the kinesiology department's isokinetic dynamometer. We use this system to measure the torque produced by the exoskeletons through its range of motion of shoulder flexion and extension. Each exoskeleton is tested across all support levels in all ranges and tested at 2 different speeds. After completing the dynamic testing of all exoskeletons, we came up with an approach to account for the effects of gravity on the recorded torque of each exoskeleton. Currently, we are working on developing polynomial equations that can be used to predict the support torque provided by the exoskeletons when in use. In addition to the meta-analysis and product testing of exoskeletons, I also got to work on the design and piloting of an in vivo biomechanics data collection. This study works on advancing the armed force field method, which is an ergonomics approach developed by my supervisor, Dr. Delfa. The armed force field model is an algorithm that predicts the manual arm strength of the population so that safe work tasks can be designed with acceptable force demands. This study is measuring arm strength at 3 positions within the reach envelope, where the arm is held at shoulder height at 3 different angles of shoulder rotation. We're measuring arm strength upon force application in the forwards, backwards, upwards, downwards, left, and right directions, and we want to see how reaching into extended positions might affect arm strength. We're also using motion capture to track scapular kinematics during these movements. Through this summer, we have been piloting this study and overcoming various challenges, including coding, participant setup, study setup, and kinematic measurements to perfect the study for data collection beginning in September. Working on these projects has been a really great way to wrap up my time at the university as a kinesiology student, and I look forward to continuing to work on these projects for the remainder of the summer. I've grown my knowledge and understanding in research substantially and will continue to apply these learned skills in my next chapter.